Okay, we were discussing real numbers. So theorem 1 was what is first theorem? Fundamental theorem of arithmetic. So what is it, Shreya? What is fundamental theorem of arithmetic? Shreya, do you remember what is fundamental arithmetic? Fundamental theorem? Panchami, can you tell me?
Ma'am, any natural number that can be written as a product of prime numbers.
Yes, okay. Shreya, see here. See, every composite number can be expressed or factorized as product of primes, and this factorization is unique. Why it is called unique? Why it is called unique? See, for example, see, 12 can be written as 2 into 2 into 3. Okay, Panchami, can you write in any another way by using prime numbers? Panchami, Shreya, can you write in any other ways?
Like 4 3s are 12.
4 3s are 12. We are right. We are taking only prime numbers. 4 is composite number. No, we are taking only prime numbers, right? By using
Ma'am, I
prime
didn't
numbers.
understand.
See, 2 to 3 are prime numbers, right? No, 12 is composite number. So I have
We have
written
to
as,
use prime numbers to write 12, like
yeah,
in different. Okay.
yeah, I have written 2 into 2 into 3. Here all are prime numbers, right? No. So can you write in any other ways by using prime numbers? Will you try?
Yes. Like we have to write it in opposite way, 3 into 2.
3 into 2 into 2. Anyway, it is 2 into 2 into 3. All are same, right? No. For example, 4 3s of 3 4s of both are same, right? No. Uh, uh, other than 2 and 3, how can you write? Can you write, Shreya? Will you try? No, you cannot write. Right? No. So you can write as 2 into 2 into 3 only. You cannot write in any other way. For example, how will you write 14, Shreya? As product of primes. How will you write 14? Shreya. Are you there, Shreya? 2 into 7. Oh, I think 2 into 7. Very good. Shreya answer. 2 into 7 or 7 into 2. See, for example, if you take first 2, 2 sevens are next, you will get 7, right? No. For example, suppose if you take 7, you will get 2 later, right? No. So, but anyway, we get the same numbers only. Okay. For example, 21. How will you write 21? How will you write 21?
Ma'am, 3 into 7.
3 into 7 or 7 into 3. Okay, that is the only one way. That is why. Did you understand why it is unique? You got it? Panchami, Shreya? That is why it is unique. Okay. So notice fundamental theorem. every composite number is can be expressed as the product of primes, and that is unique. Okay, today, yesterday we were in fifth sum, right? Let's check whether 6 and yeah, it is done, no? Did you understand this, Panchami? Yesterday you were asking, right? Check whether 6 to the power of n can end with digit 0 for any natural number n. Okay. For example, I'm explaining fifth one only. For example, if you take 10, 20, 30 or 50. See, we write the factors of, prime factors, that is 2 into 5, right now. If you write 20, 2 into 5 into 2 or 2 into 2 into 5, right now. How will you write 30? Tell me, Panchami, Shreya. How will you write 30?
Ma'am, 2 into 3 into 5.
3 into 2, 3 so 6, 6 5 so 30. Okay. Then 50 can be written as 2 into
5 into 5.
5 into 5. Okay, 5 5 25, 25 5. Yes. Okay. See, if you see all the numbers here, see in all the numbers, there is 5 right now. So 2 and 5. Right? So here the question is 6 to the power of n. Does it, what is the question? Check 6 to the power of n can end with the digit 0. See here 10, in units place we have 0, 0, 0. Here all these numbers are having the factors 2 and 5. Right now, children. So 6 we cannot write it as 2 into 5. Are you understanding? So 6 can be written as 2 into 3 whole to the power of n. So we won't get 0 in units place. Got it? Got it, Panchami? You asked me yesterday, no?
Yes, ma'am.
Okay. We'll go for the next question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 1 plus 5 are composite number. Are these composite numbers? Say yes or no. Okay, I will show you how they are composite numbers. I'll write the question once again. This is sixth question. 7 into 11 into 13 plus 13. See here, 7 into 11 into 13 plus 13. Here, 13 is common. I am taking outside the bracket. Okay. See, we know it is composite number, but you have to prove it is a composite number. Okay. See, 13 is common in both right now. So I have taken 13 outside. So what is remaining here? 7 into 11 plus, here we have 1. Right? That is equal to 13 into. So simplify this. 7 into 11 is 77 plus 1. That is equal to 13 into 78. Right? So here 13 into 78 can be written as, use prime numbers and write 2 3s are 6, 9s are 3 ones, 3 threes, next 13 ones. So 13 into 13, 2 into 3. See, we got 13 into 13, 2 into 3. And what is fundamental theorem? Composite number can be written as product of primes. Here, all are, which numbers are this? Prime number. What is product of primes? It will be composite number. Did you get it, children? Did you understand? For example, take any number. For example, take 2 and 3. 2 and 3 both are prime number. If you multiply, you will get composite number. For example, take 7 and which number will you take? 3, 5. 7 into 5. 7 and 5 are prime numbers. 7 5s are 35. 35 is composite number. Right now. So like that, see, we have got 13 into 13 into 2 into 3. So this is what? Product of prime numbers. So it becomes a composite number. Okay, good, Shreya. You understood, right? What about Panchami? Did you understand how to prove it is a composite number?
Yes, ma'am.
Okay, I will give one more sum. Same like this. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Will you try this? And tell me the answer. Will you try this, both of you? Okay. So here, this is, make it a one group and this is another group. Because we have plus here right now. So here also take 5 as common factor. You got 1008 plus 1. You got this answer, Panchami Shreya, 1009. Panchami got the answer. 5 into 1009.
Yes, ma'am, got the answer.
Okay, good. Okay, now we have 5 into 1009 right now. So product of primes means, so it is a composite number. You can write directly. Just they have given it is composite number. Just we have to show it. It is a composite number. Okay. I think Shreya understood the sum. We'll go for the next one. Seventh question, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes. Okay, Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same time. Go in the same direction. After how many minutes will they meet again at the starting point? Did you understand the question? So there is a circular path around the sports field, children. There is a circular path. So Sonia takes 18 minutes to complete one round, whereas Ravi took 12 minutes to complete one round. So if they start at the same point and at the same time, so when will they meet each other again? Okay. So let us see. Did you get any idea about this? How to find out? What do you have to find out? Shreya? I think Panchami knows the answer. Shreya? How to get the answer? See, there is a circular path. Okay. For example, it is starting point. Sonia takes 18 minutes, whereas Ravi takes 12 minutes. Okay. What about Panchami? You know the answer. What do you have to find out? How to find out?
Should we take LCM?
LCM. Okay, good. Okay. See, if Sonia and Ravi start at this point at the same time. Okay. So Sonia will take, see, for first round, I will write here. For first round, Sonia will take 18 minutes and Ravi will take 12 minutes. Correct? Huh? So for second round, so Sonia will take again 18 minutes. That means after, see, for she will complete second round at 36 minutes, right now. What about Ravi? Ravi will complete in second round. 12 plus 12, right now 24. And Sonia will take plus 18. 24, very good. Next, Ravi will take 36, right now. Next, for fourth round, 72. And Ravi will take 48 minutes for 4 rounds, right now. So, but here, what is the question? After how many minutes will they meet again, right now? See here, we have that for after completing second round. See, Sonia, she has taken 36 for second round. And what about Ravi? He has completed third round, right now? Third round. So, this is the answer. For 36 minutes, they will meet each other. Okay. So, that means what? We have to find the LCM of given number. So, given numbers are 18 and 12. So, right here, write the factors of prime factors. 2 into 2 9s 18, 3 3s 9, 3 1s 3. 2 3s are 6, 6 3s are 18. Next, 12 can be written as so what is LCM? This is 2 into 3 square. This is 2 square into 3. So for LCM, We have to take lowest or greatest power for LCM. Tell me fast. We have to take smallest power of the number or greatest power of the number for LCM?
Ma'am, greatest power of it.
Yes, greatest power of the number. Very good, Shreya. She also answered. Greatest power is 3 to the power of 2. And here 2 to the power of 2. What is 3 to the power of 2? 9. 2 to the power of 4 is 2 to the power of 2 is 4. So 36 is the answer. Okay, Sonia and Ravi will meet again at the starting point after 36 minutes. Okay. Okay, next one.
Ma'am, can I just note down the previous question?
Which one?
Ma'am, that one that you have written. The 7th question answer, ma'am.
You had to write the answer. Okay, so 1 second. Which are the numbers 18 and 12, no? So 18 can be written as 2 into 13, sorry, 3. 12 is equal to 2 2s are 4, 4 3s are 12. So write 2 into 3 square, 2 square into 3. So LCM is equal to, you have to take the greatest power of the number right now. So here greatest power is 3 to the power of 2. Here we have only 3. Here we have 2 and this is 2 square. So you have to take greatest power. So 2 square. 3 square is 9. 2 square is 4. So after, they will meet after 36 minutes.
Yes, ma'am, noted down.
Okay. And you have one more theorem, children. Okay, I will write it. I will explain the theorem, but no need to practice this. Okay, just I will explain. Theorem 8.3. So let P be a prime number let P be a prime number if P divides a square, then P divides A, where A is positive integer. Okay, this is another theorem. Let P be a prime number if P divides A square. That means what? If P divides A square, okay, then P divides A also. Okay, that means here A square is dividing by P means, then A is also dividing by P. I will give you one example. For example, take A is equal to 6. Okay. So what are the factors of prime factors 2 and 3? So 6 is divisible by 2, right? No, that is 2 1s are 2 3s are. Then now take A square. What is a square? A is 6. A square means 36. Right now. So 36 is also divisible by prime number, that is 2. 2 ones are 2 eights are. Or if you take 3, see if A is divisible by prime number, 3 twos are 6 and 6 square is 36. So it is also divisible by 13. Okay, did you understand what is the, see if a square is dividing by p, if a square is dividing by p, then a is also divide by p. Did you understand what I'm saying? If you have any confusions, you can ask me. Can you give another example? Panchami, give another example for this. What I have given like this.
Ma'am, like 14 by 7.
14 by 7. Okay, first tell me, take A is equal to or A square is equal to. Will you take A is equal to 14?
Yes, ma'am.
Okay. So 14 is divisible by 7. Right now, that means what? A is divided by P. Now write A square. What is 14 square? That is 196. So 196, that is A square. Is it, let me see, is it divisible by 7 or not? Okay, so according to this, they are saying it is divisible, right? No. So 7 ones are, sorry, you are dividing by 7, no? 7 twos, 14, 8s are 56, correct, no? As we got 28. See, A square is dividing by P. A is also dividing by P. 196 is dividing by 7. So 14 is also dividing by 7. Okay. So that is the theorem, children. Very easy. I will give one more example. What about Shreya? Did you understand? For example, take 11. Okay, you cannot take 11. Take 15. Factors of prime factors of 15, 5 into 3. So 15 is divisible by 3 or 15 is divisible by 5 right now. So it is A, it is P. So A is dividing by P. Now take A square, children. Okay, what is A square? 15 square is 225. Okay, so it must be divisible, means I'm saying the reverse. Okay, I'm saying reverse. So what is it? If A square is dividing by P, then A is also divide by P. Okay, so here 225 by 5. So let us see 7.
Ma'am, 45.
Sorry,
Ma'am, 45 answer.
which one? 45. 5 fours 20, 5 fives. Okay, did you understand? See, if A square divides by P, then A also divide by P. Okay, that is the theorem, children. And next, we'll go for the next exercise. Exercise 1.3. I'll give you example sum. Prove that root 2 is irrational. Root 2 is irrational. Okay. We know it is irrational number. Root 2, root 3, root 5, root 7. Non-perfect square root of non-perfect squares are irrational number. So here, okay, I'll teach you step by step, children. Don't worry. Okay, it is little bit lengthy but easy. Okay, I will explain you step by step. See, here we are going to prove this by contradiction method. Okay, contradiction. What do you mean by contradiction? Panchami, what do you mean by contradiction? Okay, contradiction means, see, in the question they have given it is irrational. So now we are going to prove by contradiction. That means the opposite of this, okay, is not true or incorrect. We will prove that the opposite of this is not true. Okay.
Ma'am, sorry, ma'am, wasn't able to answer, ma'am. In contradiction method, we assume that root 2 is a rational
Rational
number.
number. So at the last we will prove it is not rational number. Right now. So that is what contradiction. Okay. So by this method we are going to prove. See, opposite to this means that is rational. So at last, first we will assume it as a rational number. At the end we will prove it as it is not a rational number. So it is a irrational. Okay. See, what is the first step? Step number 1. What I told you, let us assume root 2 is a rational number. Next, step number 2. Okay, so this is our assumption. Okay, root 2 is rational number. Then what is the next step? So root 2 is equal to. So rational numbers can be expressed as, how do we express? We express as P by Q. So here I am taking A by B. Rational numbers are expressed as P by Q, where Q is not equal to 0. You know that, right? No. So I have written A by B fraction form, where A, B is not equal to 0. A and B are the integers, right? No. And one more thing, here A and B are co-primes. Okay, why we are taking co-prime means just to prove this is irrational, children. Okay, so what are co-primes? Here I am saying A and B are co-primes. What are co-primes? For example, 5 and 7. What are the factors of 5? 1, 5. Factors of 7? 1, 7. What is common here? Only 1. So these are called 5 and 7 are called co-primes. Right now, that means they do not have any common factor other than 1. Are you getting? See, this is very important here. A and B are the co-primes. Okay, so you will come to know why we have taken co-primes here. Okay, so co-primes means the number which do not have any common factor other than 1. So I am saying A and B are co-primes. Okay, this is step number 2. And step number 3 is, so I am taking this B to numerator. So B root 2 is equal to A. Okay. And next, squaring on both the sides. Because we are proving this by previous theorem, children, what I taught you now. If P divides A square, then A is also dividing by P. So by using that, we are going to prove. That's why I'm taking square. Okay. So it is b square. So root 2 means root 2 square means it is only 2. So I will write 2b square. Now a becomes a square. Did you understand till here? Step number 3. If you have any doubt, you can ask me. Shreya, Panchami. Did you understand till step number 3?
Yes, ma'am. No doubt.
Okay, what about Shreya? No doubt, ma'am. Okay, thank you. Okay, so let us assume root 2 is a rational number. So I have expressed it as a by b. Now I have taken this b to numerator and squaring on both the sides, it becomes b square. Root 2 square means only 2. A becomes a square. So here, what does it mean? See here, b square. A square is dividing by 2. Okay, I'm writing here. A square is divisible by 2. Correct? A square is divisible by 2. So A is also divisible by 2. A is also divisible by 2. So by using theorem, we have written this. Okay, call this equation number 1. Okay. Next, what I'm doing now, so we proved a square is dividing by 2 right now, children. Now I'm going to prove b square is also dividing by 2. Okay, so a square is dividing by 2. B square is also dividing by 2. We are going to prove this. Already we have proved this. Now we are going to prove that. So for that I am taking a is equal to 5. C or you can, sorry, 2. You can take any alphabet, no problem. C or K, you can take K, C, any letter, no problem. And substitute in equation 1. Okay. So what is our equation 1? First equation is b root 2, that is equal to a. Okay. So in place of a, I am writing 2c. So b root 2 is equal to 2c. So square on both the sides. So b becomes b. Tell me.
Ma'am, equation 1 was 2b square is equal to a square, ma'am.
No problem. Same thing, no? 2b square is equal to a square, no? No problem. Now, in place of a square, you write 2c whole square. Same thing. Now you will get it, Panchami. So b square, it is 2. So it square means, see, now you will get it. Okay, see, 4c square. Got it? Got it, Panchami?
Yes, ma'am.
Okay. 2b square is equal to 4c square. Then write b square is equal to 4c square by, take this 2 to denominator. Then b square is equal to 2c square. 2 ones, 2 twos. Right? B square is equal to 2c square. This means What does it mean? See, b square is dividing by 2. Dividing by 2. See, this is what we are going to prove right now. B square is dividing by 2. B square is dividing by 2. Therefore, B is also dividing by 2. Okay, till here, did you understand? If you have any doubt, you can ask me. Did you understand this step, children? I have taken A is equal to 2C and substitute in place of A. Okay, or A square, no problem. Okay, A square means 4C square. Okay, B root 2 is equal to A square on both the side. It becomes B square 2C whole square means 4C square. So 4C square by 2, it is 2C square. That means B square is dividing by 2. So therefore B is also dividing by 2. In first case, we proved A square is dividing by 2. And now we proved B square is dividing by 2. What did you understand from these two, children? Can you tell me?
Ma'am, if 2 is divisible by both A and B, then how can it be a irrational number? That's rational number.
Yes. Yes, very good. See here, see in what was our assumption? I told you I am taking co-primes, right? No, we took co-primes. A and B were co-primes. They do not have any common factor other than 1, right? No, but here what I am saying, A square is divisible by 2 and also B square is also divisible by 2. Both are dividing by 2 means it must not be a prime number. Understood? Got it, Shreya? Panchami?
Yes, ma'am.
Yes, okay. So I took A, I told you A and B are co-primes. But here, what we are saying, A square and B square both are dividing by 2. That means what? They have common factor. Right now, they have common factor other than 1. So, our assumption was wrong. That is why root 2 is irrational number. Okay, at last you should write our assumption was wrong. It is not a rational number. Root 2 is a irrational number. So very easy, children. Okay, but it is little bit lengthy. But see, first what we did, uh, express in the form of A by B, then square on both the sides. We proved A square is divisible by 2. And in this, we proved B square is divisible by 2. At last, we saw A and B. See here, they have common factors, right now. So, our assumption was wrong. Root 2 is irrational. Shall I give another sum? Will you try to do this? Same method,
Yes, ma'am.
okay? Huh. Do root 5, children. It is exercise sum, root 5. You should write all the steps, children. Let us assume root 5 is rational number. So express this as A by B, where B is not equal to 0 and A by B are the co-primes. And what is next step? Square on both the sides. root 5 square. So take this a here, sorry, b, that is equal to a square. That is 5b square is equal to a square. See, that means what? A square is dividing by a is also dividing by 5. And next, take a is equal to 5c or 5k. Anything you can take, no problem. B root 5 is equal to 5k. Square on both the sides. 5b square is equal to 25k square. So b square is equal to 5k square. That means b square is dividing by 5. Therefore, b is also dividing by 5. That means both a and b have common factor, right? So they are not co-primes. So our assumption was wrong. Root 5 is a irrational number.
Yes, ma'am, got the same answer.
Very good. Shreya, see, if you understand the steps, it will be very easy. Okay. Shreya, have you kept separate books for these classes, children? Panchami and Shreya, you have separate books, no?
Yes, ma'am.
Good. Okay. Next question is, third question. Prove that the following are irrationals. You have only 3 sums in this. First one is, see, for this same method, children, if they give root 7, root 11, root 3, root 5, root 2. So for every number, same method, but use these numbers, okay? In place of 5, you will write 3, 7, 11. That's it, okay? And remaining, everything is same. Here, first one is 1 by root 2. See here, same. Let us assume 1 by root 2 is a rational number. Okay, what is next? 1 by root 2 is equal to, express this as a by b, where b is not equal to 0. Next, b is equal to a root 2 and take this b a to denominator, that is equal to root 2. See, b by a is equal to root 2. What is our LHS here? See, this is LHS. and root 2 is in RHS. Are they both equal, children? Are they both equal or not? LHS and RHS both are equal here or not? Panchami, are they both equal or not? You are not getting my question. See, here we have root 2 right now. So you know root 2 is a rational number. What about b by a? A by b is rational number, right? No. See, we know already root 2 is a rational, but b by a, it is a rational number. So both are not equal here. Okay. So both are not equal. Therefore, our assumption is wrong. 1 by root 2 is irrational. That's it, children. Very simple.
Can you explain once again?
Huh.
I was not able to hear you.
Okay. Let's see. 1 by root 2 is equal to a by b. Right now we have expressed as a by b. This is for rational number. Then b is equal to, see, take this root 2 to numerator and b to numerator. B is equal to a root 2. Then take this a to denominator. B by a is equal to root 2. Okay. I am asking, are they both equal or not? Already we have proved root 2 is irrational number, right? No. And we know that b by a is which number? Is it rational or irrational number?
Ma'am, rational number.
Yes, this is rational number, right? No, this is rational, this is irrational. So both are not equal, right? No. So our assumption was wrong. So 1 by root 2 is irrational. That's it. Very simple. Did you understand now?
Yes, ma'am.
Huh. Right. Shreya, what about Shreya? Did you understand? Reply me. Yes. Okay, good. Next question. 7 by root 5. Sorry, we have one more second problem. Sorry, I skipped that one. We have one more question. Second one, prove that 3 plus 2 root 5 is irrational. Okay, so we know it is a rational number, right? No, but let us assume 3 plus 2 root 5. We are using the same method for all the problems here. Let us assume 3 plus 2 root 5 is a rational number. Okay, and express this as a by b. Okay, a by b, where b is not equal to 0. Then first I'm going to shift plus 3 to right hand side, children. So it becomes minus 3. So 2 root 5 is equal to, what is LCM here? B is LCM. I have written in denominator. Already we have B here. So you have to multiply only one time. That is A minus. In second fraction, we have 1 in denominator. To make it B, we have to multiply both numerator and denominator by B. So 3 into B is 3B. Got it? Did you understand this step, children? So root 5 is equal to a minus 3b. Take this 2 to denominator, that is 2b. See, what do we have in left hand side? We have root 5. What about root 5? Is it rational or irrational? It is irrational number. But a minus 3b by 2b, it is a rational number. So both are not equal. Right now, both are not equal. So our assumption was wrong or not correct or incorrect. Therefore, 3 plus 2 root 5 is an irrational number.
Ma'am, can't we use squaring on both sides?
No need to do all those things. Okay, directly we write, see, it is a rational number. Right now, a minus 3b by b, it is a rational number. It is in the form of a by b. Right now, no need to square or anything. Okay, that is only for single numbers. So root 5, root 7, we are proving. No, for that you have to do this. For this, just you have to prove LHS and RHS are not equal. That's it. What about in school, how they have given? Are they given in any other methods?
No, ma'am, same method.
Okay. So here LHS and RHS are not equal. One is, we know root 5 is irrational. Okay. So this is not equal to this. So our assumption was wrong. 3 plus 2 root 5 is irrational. Okay. You have two more sums. Will you practice at home? Same what I have done here. Same thing you have to do, children. Okay. Will you practice the remaining two sums? I did this one, right? That's it. Okay. 7 root 5 and 6 plus, I will write here, 7 root 5. And another question is 6 plus root 2. Okay, practice these two, children.
Yes, ma'am.
Okay. Okay, I think both of you understood all the concepts. No doubt, no?
No doubt, ma'am.
Okay, good. Keep practicing, children. Okay. Um, we'll continue in the next class. Thank you. We'll wind up the class. Bye bye.